Hey, thanks for tuning in to check this out with mathematics. And I encourage you to like these videos and subscribe to this channel and leave some comments and watch more videos. And so in this series of videos, we are looking at formulas that generate Pythagorean triples and the underlying concepts. And these are the three Pythagorean triple generating formulas that we've discussed previously. And in prior episode, we talked about this first formula that generates Pythagorean triples here. And we're now on the second one here. And so in this particular video, we want to look at this formula that generates Pythagorean triples. And we want to look at the expansion of this formula to show that it does in fact become a solution to the Pythagorean theorem here. And so we are going to be using this previously discussed general expansion, where if you have x plus y squared, that gives you x squared plus 2xy plus y squared, as shown in this distributive property here. Okay, and so now let's take say what we want to do here. So we're going to show that if we take 2mn squared and add that to m squared minus n squared that does in fact equal m squared plus n squared so that our formula here for generating Pythagorean triples is in fact a solution to a squared plus b squared equals c squared, the Pythagorean theorem. Okay, so let's do that. So let's take the first part here, 2mn squared plus m squared minus n squared, and let's expand those two expressions. So this would mean we need to put this squared here so that we have our a squared plus b squared. And so we would say 2 squared and m squared and n squared. So this, when we have 2mn squared, that in fact means that the exponent goes to each of the items on the inside there. And so that gives us 4m squared n squared. And then using our expansion formula here, where x plus y squared gives us x squared plus 2xy plus y squared. We can use that on our on this expression here, and so we would say we would say m squared minus 2 m squared n squared plus n squared squared. Okay, and so when you have x squared minus y squared, or x minus y squared, you get x squared minus 2xy plus y squared. And that's just a variation of this general expansion, whereas if we have this minus here, it just changes the minus here. So if this was a x minus y squared, then this would be x squared minus 2xy. And that's because we put minuses under here. Then we're going to get minuses here and here. And this one is a negative times a negative, which is a positive there. Okay, so you're probably familiar with this, but just trying to cover all the bases for anybody who might be tuning in here. So whenever you have a minus x minus y squared, that gives you an x squared minus 2xy plus y squared, because when you have x minus y and x minus y, that gives you a minus xy and a minus xy, and then the negative times the negative is the positive y squared. Okay, so that's just a little change up there. And so now going back to our expansion here, we have 2mn squared, which gives us 4mn squared, and then our x minus y squared gives us x squared minus 2xy plus y squared here. And if we continue on that, then we have m to the fourth minus 2m squared n squared plus n to the fourth and so now if you look at what we have so far, we have some like terms here. Here's a 4m squared n squared minus 2m squared n squared. So being that the m squared n squared is like this m squared n squared over here, we can say 4m squared n squared minus 2m squared n squared just leaves with 2 m squared n squared. So putting the terms in order, we have m to the fourth, and then 4 things minus 2 things leaves us with 2 things. So that's 2 m squared n squared plus n to the fourth. So 4 take away 2 gives us 2 there, and so now that's the expansion of the a squared plus the b squared. Nope. Got to catch myself here. This is n to the fourth there. Okay. Correct. Okay, so n to the fourth, n to the fourth. Okay, if you look at things long enough, you might find an error there. Okay. All right, so now let's do the the next part of our expansion here, the m squared plus n squared squared. And so if we take, excuse me there, if we take m squared plus n squared squared, that gives us, again using our expansion here, that gives us m squared squared. So this is the x plus y squared. So that's x squared plus 2 m squared n squared. That's the plus the 2xy. And then plus the y squared. That y is n squared here. So we have x plus y squared is x squared plus 2xy plus y squared. And then just to touch it up here, we have m to the fourth plus 2m squared n squared plus n to the fourth. Okay, and so that's that shows that these two statements are equal here. We took on this slide here, we took the a squared, that's the 2mn squared, and got 4mn squared, and then the m squared minus n squared gave us the m to the fourth minus 2m squared n squared plus n to the fourth. And so then when we subtracted the like terms, we had a plus 2mn squared. And then for the c part there on this slide here, that gives us the m squared plus n squared squared, and that also expanded to what we had on this slide here, m to the fourth plus 2m squared plus n to the fourth. And so this is really an elegant statement here, because what's happening here is that this m squared minus n squared squared is giving us this expansion here. And so then if we compare that to this expansion here, where it's very similar, the m squared plus n squared squared. Okay, let's actually write that down so we can see it all on one slide. So if we look at these, the m squared minus n squared squared, and that gives us m to the fourth minus 2m squared n squared plus n to the fourth. And then the m squared plus n squared gives us a very similar expression, m to the fourth minus 2 plus 2m squared n squared plus n to the fourth. So this is our b term, and this is our c term here. So our b term, that is the m squared minus n squared, gives us this expansion here. And the c term, that's the m squared plus n squared, gives us this expression here. And you can see that they are almost exactly alike. This is a minus 2m squared, and this is a plus 2m squared here. And so with the other part of it, that's the 2mn squared. That's our a value. Okay, that gives us 4m squared n squared. And so if we look at them like this, where we write all three of the parts down, m to the fourth minus 2m squared n squared plus n to the fourth, and then m squared plus n squared, squared, that gives us m to the fourth plus 2m squared n squared plus n to the fourth. Okay, so if we write down all three of them, the a squared and the b squared and the c squared, we can see really what's happening here is that the b squared and the c squared are giving us the same things here, m to the fourth and n to the fourth and n to the fourth and n to the fourth. And the a is saying 4 minus 2 is 2 there. So that's very elegant. That's why it works, because we're using this one to make this expression become this expression. And that's all we need. Okay. So that is actually Euclid's formula for generating Pythagorean triples. And it's quite simple and elegant in that way that it works here. Okay, so now in the next video, we're going to talk about this formula that generates Pythagorean triples here. And so I encourage you to watch the next two videos about that, about this formula here. And that will complete all this comprehensive examination into the Pythagorean theorem and Pythagorean triples and formulas that generate Pythagorean triples as I've been presenting. And so thanks for tuning in to Check This Out Mathematics. And I encourage you to like these videos and subscribe to the channel and leave comments down below and watch more videos. And thanks for tuning in. And again, this is Mr. O'Donnell signing off.